Dear students, in today's module, we will learn about hexadecimal notation. It is just a representation for easiness of humans to process binary numbers. You know that binary numbers are sometimes very large. For example, we have seen in the previous modules that when you are going to store A as a binary number, then it is translated to 65, and that 65 has a large binary number which is 01000001. So such a number is very difficult for humans to remember, and in this module we will try to summarize and comprehend such large binary digits to smaller symbols so that it can be understood easily by the humans. So, as I already mentioned, that bit patterns are large, and sometimes such a large bit patterns are also known as streams, and understanding large sequences is difficult for humans, and we use shorthand notation. It represents 4 bits as single symbol. This means if you have 8 bits, so those 8 bits would be converted to 2 symbols in hexadecimal notation. And why 4? Because computer sequence is multiple of 4s. So this is the representation or hexadecimal representation for bit patterns, because we have 4 bit pattern that would be represented to 1 symbol. So each bit pattern has a unique symbol. For example, if you come across with a bit pattern 0000, so that would be represented with a hexadecimal notation only 0. And then if you have 0001, so that would be translated to 1. 0010 would be translated to 2 up till 9. After that we have 1010, which is basically 10. But if we write 10 here, then we are not going to save one symbol in hexadecimal notation. So that was our motivation, that for each of the bit pattern there should be only one symbol. So we cannot write here 10 because these would be 2 symbols. So therefore we have translated 1010 to a symbol A, and similarly 1011, which is 11, is translated to B, C, D, E, F, and this is the maximum bit pattern 1111, which is translated to a symbol F. And you should recall the previous module that if we have a bit pattern of 4 bits, then the maximum patterns which can be formed are 2 raised to power 4, which are 16, and these are 16 patterns you can count: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So these are the all possible 16 combinations in 4 digits, 4 binary digits, and for each of the bit pattern we have written one typical symbol. So whenever we see this pattern, we will represent this pattern with the corresponding symbol. So let's have some examples. This is a question number 5, B part on your book, page 38. So we have to convert a binary hexadecimal, this one, to hexadecimal notation. So this is a binary and we want to convert this binary to hexadecimal. So in here you have learned that you need to combine 4 pairs, and those 4 pairs should be translated to the corresponding hexadecimal notation. So therefore in the next line I have made pairs of 4. So this is first 4 pair, then second 4, and so on. So you can see the first pair 1110, where you can see 1110 here. So that is E. So against this you need to write E. Then you have 1000, which is 8. Then you have 0101, 0101, which is 5. Then you have again 0101, which is 5. Then you have 0001, which is 1. And then 0111, which is 7. So such a large number which has 1, 2, 3, 4, 5, 6, 6 into 4, 24 bits. So these 24 bits were difficult for human to remember, to recall, to comprehend and to use. But these 6 symbols could easily be comprehended and understood by the humans. So you do not need to say all of this number. You need to say this number is E85517 in hexadecimal notation. So remember that this hexadecimal notation is only for the humans to understand. This is not for the computer. Computer still saves information in the binary digits. Similarly, there is another example that we want to convert hexadecimal to binary. So we have 0100. So when we want to convert hexadecimal to binary, then you want to come from here to here. So in hexadecimal, you need to see where is 0. It's here. And against 0, you need to write down the whole bit pattern, which is 0, 0, 0, 0. Right? So do not be confused with single 0 and 4 zeros. Single 0 is a symbol in hexadecimal notation, and 4 zeros are basically the actual bit pattern that has been stored in computer. And then you have 1. So again we will go from hexadecimal to bit pattern. So we have 1 here, and against 1 we have pattern 0001. So write 0001, and then for again 0, 0, 0, 0, 0, and for again 0, 0, 0, 0, 0. So now you can see that this number, if you want to remember it for future usage, it is very difficult to comprehend and to remember this number. But in hexadecimal, the same number was represented by 0100. So it is very easy to comprehend. So if we summarize today's module, we have learned about hexadecimal notation. We have formed a motivation that why we need hexadecimal notation to understand, and why we need only 4 bits, and then how they are represented. And we ended up with 2 examples, one conversion of binary numbers to hexadecimal, and then converting hexadecimal to binary numbers.